Welcome to Skymap Viewer, a browser-based astronomical information system designed to put LIGO Virgo sky maps into an astronomical context. You can see sky maps from the discovery events of LIGO, and you can also see some simulated sky maps. Here's a random one of them. You can click here, but I've already picked out one of the sky maps. Here you see the Milky Way and the Sun and the Moon, and this is the sky map itself. It's a probability distribution for the location of the source of gravitational waves, and some sky maps are two-dimensional, just probability on the sky itself, and some three-dimensional which also have distance. There are 9 contour lines. The outer one has 90% of the probability, then 80%, 70%, etc. to this inner red one, which has 10% of the probability. There's a choice of background for the display. As you see when we zoom in, the images are dynamically fetched. Let's move to a different survey. This one is the Mellinger sky. It's very good for wide panels. Let's look at the digital sky survey, the DSS here. Doesn't look so good when you're far out. Now use this plus sign to zoom in, and suddenly the DSS has a lot more at quite deep fields of view. Another survey that we have is the Sloan Digital Sky Survey. So here's another view, even deeper. There's a couple of galaxies here, I see. These stars are in our Milky Way and are very close to us. These galaxies are much, much further away. That's what LIGO is more interested in. Zoom back out again with this minus sign all the way out. We can have the ROSAT X-ray survey. We can have the Galax ultraviolet survey. We can have the Fermi sky, the gamma ray sky. Let's go back to Mellinger again. I'd just like to say that we can put in time and place for looking at the sky. Let's click now, and you see it says 2016 August 14th. That's now. And let me put in my longitude and latitude. I'm in Pasadena, California at minus 118 longitude and 34 latitude, and then you do show sky. And so we see that the south at the bottom, the north at the top, the east at the left, and the west at the right, and the sun has just passed its zenith because it's early afternoon. But let me change the time a bit to put the sky map in the middle. There it is. This is right around sunset, and we have a gibbous moon rising in the east. Okay, so those are the things the observer already knows, where is the sun and the moon and so on. But let's do some astronomy here. Let's ask, where are the big masses of stuff that are likely to have the event that we're going to use as an astrophysical prior? Let's take a look at another sky map. And let's take a look at the sources from the GLADE catalog here under observation targets. And now you see quite a lot of extra stuff has appeared. Let's zoom in with the plus sign, and you can see that the sky map has all of these squares on it. We can make these squares a bit smaller here by clicking make targets smaller, but the relative sizes of these squares is about how much astrophysical prior there is. The area of each square is proportional to the mass of the galaxy in there times the sky map probability density. if you double click on one of the sources, it has two effects. Firstly, the source is brought to the center so that now when you zoom, you're zooming around that center. And it also brings up this pink panel of information, and it's telling you information about the source. This thing is 197 megaparsecs, and it's 47 terasuns, 47 trillion times the mass of the sun. Let's get a better survey. Let's see if Sloan covers here. Yes, there we are. And maybe you can already see the galaxy down in the middle here. Let's zoom a bit more. That's it. So this is the thing that this edge-on galaxy, this is what we're pointing our telescopes at, because that's where the mass is, and so that's where we expect the LIGO-Virgo event at 100 megaparsecs to be. These stars here are in our Milky Way. They're very close. They're not important for the purposes of this discussion. Let's look up at the top here. It tells us that the sky map we're looking at has a distance estimate of 100 plus or minus 20 megaparsecs. And we see that the distance of this source from the Glade catalog is 97 megaparsecs. These objects have been selected on the basis of the position on the sky and their distance. Let's see what else we can look at. If we zoom back out again, we see there's a whole tail of other Glade sources out here. Even though the sky map is obviously quite low, we've got 90% of the probability down here, but there must still be some probability here. Let's close in on here a bit. Let's look at some of these other catalogs. Let's see, we have the Gravitational Wave Galaxy catalog, which is an earlier version, an earlier catalog for gravitational waves. And then we have these catalogs of much further out things, including, for example, this one, the Abell clusters as confirmed from ROSAT. Here's some more cluster survey. Now it looks to me like there's something pretty serious going on down in here. Let's just concentrate on that one. And I double click it to center it, and we see it's A2199, which is the Abell cluster, a galaxy supercluster. It's at 126 megaparsecs, which is quite within our error estimates from gravitational waves. But we also see that it's 1500 terasuns. It's a much larger mass than those galaxies that are down in the most likely part of the sky map. And so because the mass is so much higher, it cancels out the fact that the sky map is so much less, the probability. Now when we zoom in on Sloan, we see a jolly nice galaxy cluster. I'm sure we could find some lensing if we looked hard there. Let's just look in some other wavelengths while we're here. Here in ROSAT, yes, the X-ray gas in between the galaxies of the cluster is very hot and emits X-rays. In fact, the MCXC catalog is showing up X-ray detected clusters. There's another one here. One more thing is that we can drill down with Simbad and with Ned, giving us all sorts of other information about what might be here. I think I'll call it a day now, and thank you for listening. I'd like to thank my colleagues at CDS Strasbourg for making the Aladdin Light platform on which Skymap Viewer is built, and much of the information services that we're using. Thank you so much.